Each time the furnace switches on, nearly 30% of the heated air escapes through gaps hidden above your ceiling. It drifts into the attic, the crawl space, and the empty cavities inside the walls. Money spent heating your home ends up warming the space between the roof and the ceiling instead of the rooms where people actually live. The solution is surprisingly simple. A white ceiling compound brushed across duct joints with a $3 paintbrush. About $1 of material seals a single connection. $15 is enough for an entire house. Meanwhile, the silver tape sitting in most garages, the one people assume was made for duct repair, is prohibited by building codes across much of the country for that exact purpose. The product named after ducts is notorious for failing on them. What is happening behind the walls has been studied for decades. Researchers at Lawrence Berkeley National Laboratory spent more than 30 years surveying residential duct systems. Their measurements across thousands of homes revealed a clear pattern. Around 10% of the air force through supply ducts leaks out before ever reaching a vent. Another 12% disappears through the return side, pulling air from unconditioned areas instead of the living space. Combined together, the average American home loses 22% of its heated or cooled air through duct leakage alone, and that is only the average. Newer houses with sloppy construction, older homes with deteriorated seals, and systems rushed during installation regularly exceed 30% losses. Officials from the California Energy Commission estimated that standard new homes leak almost exactly 30%. In separate field measurements conducted by LB&L, supply-side losses alone reached 35%. Return side leakage climbed as high as 73%. Consider what that means in practice. A homeowner pays the gas bill. The furnace ignites. The blower moves 1,000 cubic feet of heated air every minute into the duct network. 300 cubic feet never arrive at the vents. Instead, that air pours through seams and joints into the attic. Because attics are vented outdoors, the heat ultimately escapes outside. Money paid for warmth ends up heating the open air above the roof. The reason these systems leak so badly comes down to construction. Residential ductwork is not a single continuous structure. It is assembled from many separate sections. A rectangular plenum attached to the air handler, a trunk line extending outward, branch takeoffs feeding round ducts into individual rooms, register boots connecting to ceiling or floor vents. Every transition creates another joint. A standard house can contain dozens of these connections. Each one is held together with sheet metal screws, then sealed with whatever material the installer happened to use that day. Most of those joints sit inside harsh environments: attics, crawl spaces, garages, empty ceiling voids, areas that reach 130 degrees during July and drop to 40 degrees in January. The damage does not happen only once. When supply ducts leak into the attic, heated air is lost immediately. But the house pressure also changes. Air leaving through the duct walls means less air reaches the rooms. That pressure imbalance then pulls unconditioned air back into the return ducts through every weak seam and connection. The furnace begins drawing freezing attic air into the intake system and reheating it from the beginning. The homeowner pays to heat the original air. That air escapes. Then more money is spent heating replacement air sucked in from the same attic. Engineers at Energy Vanguard describe the process with a simple phrase: duct leakage steals twice. The history of duct tape itself traces back to wartime America. In 1943, a woman named Vesta Stout worked inside a munitions factory in Illinois, packaging rifle cartridge boxes. Those boxes were sealed using paper tape coated in wax for waterproofing. Soldiers in combat struggled to open them because the pull tabs often tore away under pressure. Stout wrote directly to Franklin D. Roosevelt and suggested creating a durable waterproof cloth tape. Her message reached the War Production Board. Within months, a division of Johnson & Johnson developed the product. It used cotton duct cloth combined with rubber adhesive and waterproof coating. Soldiers called it duct tape because water rolled off its surface. After the war ended, the housing boom began. After the war, America entered a massive housing boom. Tens of thousands of homes were rising across the country, many equipped with forced air heating. Those systems required duct networks. The ducts needed sealed seams. Manufacturers took the leftover military tape, changed its color from army green to silver so it matched galvanized steel, and promoted it as the perfect answer for HVAC work. That was the moment the name shifted. Duct tape became duct tape. During the 1950s, a product inherited the name of a task it had never been engineered to handle. For the next 40 years, millions of American duct systems were wrapped with it. No one had seriously examined whether it could survive long-term use. People simply assumed it worked. Then, in 1998, two researchers from Lawrence Berkeley National Laboratory decided to put that assumption to the test. Max Sherman and Ian Walker created an accelerated aging setup inside their Berkeley laboratory. They assembled sample duct joints and sealed each one using different products available on the market: clear tape, foil-backed tape, mastic sealant, aerosol compounds, standard cloth-backed duct tape. The experiment pushed 160-degree heated air and 50-degree cold air through the duct sections every 5 minutes for 3 months straight. The process recreated the repeated expansion and contraction real HVAC systems experience over years of operation. Sherman later summarized the outcome with brutal simplicity. Out of every material tested, only duct tape failed. It failed consistently and sometimes in catastrophic fashion. 11 separate duct tape samples broke down within days. Some peeled away from the metal, others hardened until they cracked apart. Several lost adhesion completely and dropped from the joints, leaving behind dead rubber residue smeared across the sheet metal surface. One sample failed before testing even began. It had remained on a workbench for 1 week, and during that short time, the tape curled itself off the duct connection while trying to return to its original shape. The material was literally pulling itself away from the duct before entering the machine. Only one cloth-backed tape survived from the entire batch. Every other successful sealant came from different technologies. The mastic coatings held. The foil tape remained intact. Aerosol sealant survived the full 3-month cycle without issue. Duct tape alone collapsed under the stress. The study exploded into national headlines. Stories appeared in the New York Times, the Washington Post, the Chicago Sun-Times, and dozens of additional papers across the country. NPR covered the findings as well. Sherman was even invited to speak during Harvard University's Nobel-themed ceremony that same year because the event focused on duct tape. The conclusion from the research was impossible to misunderstand. Building codes eventually changed because of it. Section MOST 1.4.1 of the International Residential Code, the model standard used by most states, requires duct joints to be sealed using materials approved under UL 181A or UL 181B specifications. Standard cloth-backed rubber adhesive duct tape qualifies for neither category. It fails both tests. Section 603.9 of the International Mechanical Code repeats the same requirement. California pushed even further. Title 24, Energy Code Section 120.4 B1D specifically bans cloth-backed rubber adhesive duct tape from use on duct joints. In simple terms, across most of America, the product called duct tape is not legally approved for sealing ducts. Despite the name, despite being stocked in nearly every hardware store, despite packaging covered with pictures of shiny silver ductwork. The product carried the identity of the job first. Then, scientific testing proved it failed at that job. Afterward, the building codes formally prohibited its use for that same purpose. Yet homeowners, and even many contractors, still continue using it because most people never heard any of this history. The material that actually works is called duct mastic. It is a water-based compound with the texture of thick cake frosting, sold in quart and gallon containers in the HVAC section of hardware stores. Products such as Hardcast, RCD, and DP10 all fall into that category. A quart container usually costs between $12 and $18. That amount is enough to seal every reachable duct joint inside a normal house, roughly $1 per connection. The application process is simple. Spread the mastic over the seam using a disposable paintbrush. A gloved finger works just as well. If a gap exceeds 1/4 inch, place fiberglass mesh tape across the opening first, then coat over it with the mastic. Within a few hours, the material cures into a hard but flexible seal. Unlike rubber adhesive, it survives constant temperature cycling without degrading. It does not peel away, it does not curl. Estimated lifespan ranges from 15 to 30 years, often longer than the furnace itself. The LBNL testing rig examined mastic beside the duct tape during the same experiment. The mastic survived the entire 3-month stress cycle without measurable deterioration. The comparison was not even close. So why has the public barely heard about any of this? Because nobody involved has much incentive to explain it. Manufacturers producing duct tape are not eager to advertise that their product fails at the very task associated with its name. Hardware stores stock both products and profit either way, regardless of which one customers choose. When some rooms stay cold while others overheat, the HVAC contractor arriving at the house is usually there to charge for a visit. A $15 bucket of sealant and a free Saturday afternoon do not create profitable service work. A $3,000 duct sealing contract does. A $9,000 furnace replacement is even better. And this is how the cycle keeps repeating. An installer uses cloth-backed tape on the duct joints. That installer wins the contract because the bid comes in cheaper than competitors using mastic. 2 years later, the tape begins failing. The house struggles to maintain temperature. The homeowner calls an HVAC company. The company diagnoses the furnace as undersized. The homeowner spends $9,000 on a replacement unit. The new furnace pushes more airflow through the exact same leaking ducts. Energy bills rise again. Everyone involved in the chain gets paid except the homeowner. This is not some hidden conspiracy. Nobody buried the research. The LBNL findings appeared on the front page of more than 3 dozen major newspapers. Building codes changed publicly afterward. The reality is simpler. The residential HVAC industry earns money through service appointments and equipment replacement, not through a $15 container of sealant that can last 30 years. Before attempting repairs personally, there is one important limitation to acknowledge. Some duct joints are hidden inside walls or blocked behind equipment. Homeowners cannot physically reach them. Professionals using a duct blaster and an AeroSeal system can locate and repair leaks inaccessible to ordinary tools. That is why complete professional sealing services usually cost between $1,500 and $4,000. Sometimes that expense is justified. But for the accessible 70% of duct joints, the ones sitting in attics, basements, and crawl spaces, the work can often be done personally for little more than the price of lunch. Those exposed sections are usually where the largest leaks exist anyway. The process itself is straightforward. On a Saturday morning, pull on old clothes, grab a flashlight, and head into the attic or basement where the duct system runs. Turn the furnace on. Slowly move your hands along every seam. Check where branch ducts split from the main trunk. Feel around, register boots where they meet the ceiling drywall. Leaking joints reveal themselves immediately. Warm air pushes against your hand wherever the seal has broken. Mark those spots with chalk. Then shut the furnace down. Open the container of mastic. Dip the brush into the paste. Spread it over every seam, screw head, joint, and connection point. Give special attention to the plenum because the largest leaks are commonly found there. For openings wider than 1/4 inch, place fiberglass mesh over the gap first, then apply mastic across the top. Allow everything to dry overnight. The next morning, switch the furnace back on. Rooms that once refused to stay warm begin holding heat again. A master bedroom that constantly stayed 5 degrees colder than the thermostat reading matches the rest of the home within a single day. The furnace finally cycles off instead of running continuously. Then the utility bill changes. The next gas statement often drops between 10 and 20% on a typical yearly heating and cooling expense of $1,500. That equals savings between $150 and $300 every year. Across the lifespan of the duct system, homeowners stop sending somewhere between $3,000 and $8,000 to the gas company. The total cost to reach that point remains remarkably small. $15 for a quart of mastic, $8 for mesh tape, $3 for a brush, $26 total, and roughly 4 hours of weekend work. And the leak test itself requires almost nothing. No duct blaster, no smoke machine. Just a stick of incense from a hardware store or pharmacy for about $3. Light the incense, turn the furnace on, walk beside every exposed section of ductwork while holding the smoke near each seam. Supply ducts operate under positive pressure. If smoke blows away from the joint, conditioned air is escaping through a leak. Return ducts operate under negative pressure. If smoke gets pulled inward, the furnace is sucking attic air back into the system through an opening. Either reaction means leakage exists. The entire inspection takes around 15 minutes. Every house has leaks somewhere. The only question is how severe they are. The point that keeps resurfacing goes back to 1998. 2 researchers published a study proving the tape named after ductwork failed at sealing ductwork. The research reached major newspapers nationwide. Building codes changed afterward. By most practical interpretations, the product became prohibited for the exact use attached to its name. Yet more than a quarter century later, that silver roll still sits inside garages across America. Meanwhile, the sealant that actually works remains only a few aisles away in the same hardware store, and most people still have no idea there's a difference. One product carries the famous name. The other quietly does the job. If this is the kind of information worth hearing, stay tuned for the next story. Please leave your thoughts about this content in the comments below. Thanks for watching. See you in the next one.